Hello student, welcome to my official YouTube channel Mathematics All Level by Akib Khan, and here we are discussing the previous year questions of previous year question topic wise. So today's topic which we have taken is product and quotient rule of differentiation, which is the most searched topic on the YouTube for Edexcel A-Level examination students. So this all question was asked from 2021 to 2024 students. So whatever questions I have taken here, it belongs to the differentiation topic, and it belongs to this particular topic, that is in differentiation it belongs to this particular topic, that is product and quotient rule. And in case if you have any query, so you can mail me here students on femaspace@gmail.com. So let's see that how we should attempt these questions. Okay. The first part is given that a car stops at two sets of a traffic light, and figure they have mentioned in the question, and the speed of the car is v meter per second. Speed of the car is v meter per second. The car takes t seconds to travel between the two sets of a traffic light. The speed of a car is modeled by the equation. Speed of a car is modeled by the equation student 10 negative of 0.4 t into log of t plus of 1. Okay, where t is in the range of less than or equal to 0 and greater than or equal to 0 and less than or equal to capital T. So in the first part student, they have told where t second is the time after the car leaves the first set of a traffic light. According to the model, find the value of capital T. So if I say you students, set at capital T, this is the capital T students, what is the velocity here? Velocity will be 0. It is clearly observable students. See that velocity component at capital T is 0. It means, okay, this is the model for velocity. Now velocity component is 0, so we will be plugging the value of velocity component is 0 students. Okay, so it means that this will be 0, velocity will be 0. So 10 negative of 0.4 t log of t plus of 1. Now one more thing students, since we are calculating for the time interval capital T, so this velocity here is 0, so this will be capital T and this part will be also a capital T. So we'll be writing it here, this part as capital T and this part also as a capital T, t plus of 1. So here we can say that product of two components is equals to 0. So either this part must be 0 or this part must be 0. So let's say this part is 0, this part, first part. So 10 negative of 0.4 capital T is equals to 0. From here what we'll get, 10 equals to transposing 0.4 t to the right hand side, so we'll get 0.4 capital T. If I do it further, so we'll get 10 equals to, this could be written as 4 by 10 cross t. On solving it further, what we'll get t equals to 25. Okay, this 10 cross of 10 upon this 4 will be in the denominator part, so we'll get 25 here. Okay, so we have got the value of t as a 25 students. Now next part is show that the maximum of the speed of the car occurs when t is given by certain equation. Maximum speed of the car is, it means we need to, whenever this concept is asked, maximum or minimum or stationary point, this means that we need to differentiate the function. So whatever the model is given here, so we need to differentiate here, students. Let's differentiate it. So v is given as 10 negative of 0.4 t. This is given. Log of t plus of 1. Log of t plus of 1. Okay. So if I say that if what we can write here, we can do it further for after further calculation. What we can do here, student, 10 log of t plus of 1 negative of 0.4 t into log of t plus of 1. Okay, this could be written 10 log t plus of 1, and this again could be written as 4 by 10 cross of t log of t plus of 1. On further calculation, we'll get 2 by 5. We are getting this value as v. Now if I differentiate this function with respect to t, because they have asked for the maximum speed, so the concept of differentiation will be here. So dv by dt will be equals to, okay, first let's talk about this function. So it will be 10 cross of the differentiation of log of t plus of 1, that will be equals to t plus of 1 into 1. Okay, how we have got it? Those who don't know, I'll be doing it here as well. D by dx of log of x, this is the formula, student. It will be equals to 1 by x dx. Okay, this formula we have applied here. T plus of 1 will be into the negative part, cross of 1. Now next, again differentiation, that is 2 by 5. Okay, I'm writing like this. This function we can see here that here are two functions, t cross of log of t plus of 1. So we'll be applying the product rule here, students. We'll be applying product rule here. So first part differentiation, the second part will be written like this: log of t plus of 1 plus of t into the first part is written now, and second part differentiation, again log of t plus of 1 differentiation, it's t plus of 1. Okay, since we need to find the maximum point, maximum speed, so again dv by dt will be equals to 0, then only we will be able to find the t value. So this we are keeping this as a 0, so what we'll get, 10 by t plus of 1, 10 by t plus of 1, we will transpose this part into the right hand left hand side. So what we'll get, 2 by 5. Okay, log of t plus of 1 plus of t by t plus of 1. Okay, so we can calculate it here itself, that we will get 2 5. So 25 by t plus of 1, 25 by t plus of 1 equals to log of t plus of 1 plus of t by t plus of 1 plus of t by t plus of 1. So if I take the LCM here, students, what we'll get, 25 by t plus of 1 equals to t plus of 1, we have taken the LCM here, students, into log of t plus of 1. If you don't know that what I have done here, just multiply the whole expression with t plus 1. Okay, or we can say that here the denominator part will be 1, so we have taken the LCM, plus of t upon t plus of 1. Now multiply whole equation with t plus of 1, this part. So this part and this part got cancelled. So what we'll get, 25 equals to t plus of 1 log of t plus of 1 plus of t. T transposing this t to left hand side, so we are getting 25 negative of, okay, leave it. So we'll get 25 equals to, expand this part, so we'll get t times of log of t plus of 1 plus of log of t plus of 1 plus of t. Now what we need to do, just take a log of t plus 1 to the left hand side, so we'll get 25 negative of log of t plus of 1 equals to this part, and this part will be remaining, taking t as a common, so you will get t times of log of t plus of 1 plus of 1. Okay, so from here, if we will calculate it further, we will get the value of t equals to 25 negative of log of t plus of 1 upon log of t plus of 1 plus of 1. Okay, so here if I arrange this particular part, this we have got in the question, student, they have told that t is equals to this part. So can we write this function 26 by 1 plus of log of t plus of 1 negative of 1. This particular function could be written like this. If we calculate it, if we take the LCM here, so we will get this value. Okay, after calculating this part, we will get this. So we have arranged this part into this part. So here why we did this, because we need to follow the iteration part, students. See, iteration part is given here. So this is, student, t n plus of 1 iteration we need to follow now. 26 upon 1 plus of ln t n plus of 1 negative of 1. This is the iteration part which we need to follow here. Yeah. With t1 equals to 7, find the value of t3 to 3 decimal places. t1 is equals to 7, students. t1 is equals to 7. So on keeping t1 equals to 7, what we'll get? t1 is equals to 7, and the given equation was, I'll write the equation again, student. Tn plus of 1 is equals to 26 by 1 plus of log of Tn plus of 1 negative of 1. Okay, so on keeping n equals to 1, so what we'll get? T2 equals to 26 upon 1 plus of log of T1 plus of 1 negative of 1. Okay, so just plug the values here. So it will be 26 upon 1 plus of log of T1, the value of T1 is 7, so it will be log of 8 negative of 1. On calculating it further, what we'll get? Okay, 26 divided by 3.079. Eight point of 44 negative of 1 will get 7.443. 7.444. Okay. Similarly, if I say what about 3, so again just need to plug the value of n equals to 2 here. So we'll get 26 upon 1 plus of log of T2 plus of 1 negative of 1. On calculating it further, keep this T2 value from there to here, so you'll get 26 upon 1 plus of log T2. T2 is 7.44 plus of 1, that is 8.444. negative of 1, that will be equals to, so we need to calculate it here, students. Log of 8.444, that is 2.13, plus of 1, that is 3.133. 26 divided by 3.1333, we are getting 8.29, negative of 1, that is equals to 7.297. So this is the value of T3, students. Yeah, so we need to find the T3 to 3 decimal places. So we have got the value of T3 to 3 decimal places, that is 7.297. Now in the next part, find by repeated iteration the time taken for the car to reach the maximum speed. Time taken for the car to reach the maximum speed. A repeated iteration. So just we need to do, what we need to do, just need to plug in the values continuously. So whenever the values is not changing, means whenever this particular value is nearly same for the repeated iteration method, so this will be the maximum value. So again what we need to do, we will be plugging the value of T4. So to T4 will be equals to 26 upon 1 plus of log of T3, we have got 7.297, so it will be log of 8.297, negative of 1. So I'll tell you the values here. Log of 8.297 plus of 1, that is 3.115. 26 divided by 3.115, that is 8.34, negative of 1. So we will getting 7.346. Similarly for T5, again same thing, same process we need to repeat. 26 upon 1 plus of log of, for T4 again we need to plug, so it will be 8.346, negative of 1. So what we are getting here, log of 8.346 plus of 1, 3.121, negative of 1. So we are getting 7.3306. For T4, T5 we have got. Now what we need to do, we need to find it for T6 as well. Usually in 3 iterations we get the values here, students. For T6 again what we need to substitute T5, so it will be 26 upon 1 plus of log of 7.33 plus of 1 will be log of 8.330, negative of 1. So if we calculate this part, what we will get, 33, we are getting 2.11, plus of 1 we are getting 3.119. so negative of 1, so we are getting, student, 7.336. So from here, student, we can see here that see, from here we can observe that this is the part where it is getting stagnant. See, so this will be the maximum point of T. The time taken for the car to reach maximum speed will be approximately 7.33. So time will be approximately 7.33. Okay, by repeated iteration we have proved that T4 is also nearly 7.33, 7.33, 7.336. Okay, so this will be the time taken to reach the maximum speed. Now come to the next question, student. See, the function f is defined by fx equals to e power 3x upon 4x square plus of k, where k is a positive constant. Show that f prime x is equals to 12x square negative of 8x plus of 3k, into gx. This is the function which they have given. Okay. So if I say that this is the function they have given, so we need to find the differentiation part, that is f prime x is equals to we'll apply the quotient rule here, students. So what we'll get in the denominator, we'll get 4x square plus of k whole square. Now this part will be written directly, that is 4x square plus of k into differentiation of the numerator part, that is equals to 3 times of e to 3 to the power 3x, negative of differentiation of the denominator part. So the differentiation of the denominator part will be 8x into e raised to the power 3x. Okay. On calculating the numerator value here, this is the first step. Now second step, numerator value, what we are getting here, 12x square plus of k 3k into e raised to the power 3x negative of e raised to the power 3x into 8x upon 4x square plus of k whole square. If I take e power 3x as common from here, student, what we'll get on the numerator part, we'll get e raised to the power 3x on the numerator side. If we are taking e power 3x as a common here, so we are getting 12x square plus of 3k negative of 8x upon 4x square plus of k equals to 4x square plus of k whole square. Now see the question. They have asked that show that this particular f prime x is equals to 12x square minus of 8x plus of 3k. See, we have got this value. Cross of gx. What will be gx here? What will be gx here, students? According to our solution, gx part will be e power 3x upon 4x square plus of k whole square. This is gx, students. Given that the curve with equation y equals to fx has at least one stationary point, we have found the gx, student, according to the question. First part is done. In the second part, given the curve with equation y equals to fx has at least one stationary point, find the range of possible values of k. See this part first. K is a positive constant, students, here. So it means that k will be greater than 0. From here we can say it is a positive constant. So it means k will be greater than 0. So first range is here. Now for the range of possible values of k. Okay. Let's see this. If we are writing this particular function again, so f prime x will be equals to 12x square plus of 3k, 12x square plus, either we should write negative, minus of 8x plus of 3k, see here, into gx. Okay, this is there. Now for gx, students, see, for gx, see here, this will be a positive part, numerator, this will be positive always, and this will always be positive. Why is this so? Because any value if we are plugging in here, so we'll get the values as if we are taking the square of that particular value, so it will be a positive value. Okay, so the numerator and denominator both part will be positive for gx. For talking, if you are talking about range, students, so this part must be equals to 12x square negative of 8x plus of 3k. For this part, if it is greater than 0, so for this part, if we are taking, see, the product of two function f prime x, if it is greater than 0, okay, because f prime x we are calculating here, see, has at least one stationary point. It means it is having one stationary point. So for this part, if we say this part 12x square minus of 8x plus of 3k, it must be factorized, or it must have any particular root, then only we will be able to get the one stationary point. So it means if I say about discriminant part, for getting the real roots, students, what will be the condition? These should be greater than or equal to 0. Then only we will be able to find the value of x, which will be a stationary point. So for here d is greater than or equal to 0. What is a here? A is 12, b is minus 8, c is 3. So it means b square minus of b square negative of 4ac must be greater than or equal to 0. So if we plug the values here, so it will be 64 negative of 4 times of a into c, 4 times of a into c, that is 3. This must be greater than or equal to 0, then only the real roots will be possible for x. Okay, so if the real roots will be possible, then only we will be able to find the stationary point. So what we'll get here, c will be 3k, so we'll get 3k, we'll be writing 3k here. So it means if I say yeah, transposing this part to the right hand side, so we'll be getting 64 is greater than or equal to 4 times of 12 cross of 3k. If we are solving it here, students, yeah, so what we'll get, yeah, 3k will be less than or equal to 64 upon 4 cross of 12. Okay, so from here we can say k must be less than or equal to 64 divided by 48 cross of 3. So if we solve it further, we'll get 4 1. So what we are getting here, student, k must be less than or equal to 4 by 9. Okay, so k must be less than or equal to 4 by 9, then only the value of x will be able to find. And if we are able to find the value of x, then we will be able to find the stationary point. And in the first part I have written here, see, k must be greater than 0, then only it will be a positive constant. So on combining this both ranges, what we are getting, first part this is there and this part is here. So on combining first and second equation, what we are getting, k must be greater than 0. This was from first statement. Second statement is k must be less than or equal to 4 by 9. It means the k will lie between greater than 0 and it must be less than or equal to 4 by 9. So this is the possible range, students. If you want to conclude it like this, if you want to plot it like this, see, this is 0, this is 4 by 9. So from first k is greater than 0 means this part will be included. From second k is less than or equal to 4 by 9 means this part will be included. So the common range which will be here, which will be this. Okay, so k must be in the range of 0 to 4 by 9, where 0 is excluded and 4 by 9 is included. Okay, so this is the possible value of range of k. Okay, students, so these two questions were asked from product and quotient topic of differentiation, and in the year 2021 to 2024. If you have any type of query, you can mail me here. And if you have any type of a query or any type of a doubt you are facing with, so you can comment me in the box. Hope you like my video. Share this video to your fellow colleagues or fellow students, and don't forget to like my content. Thank you.